Since rational expressions are fractions, I want to review how we reduce fractions just to lay a good foundation. Now, if we had a fraction like 26 over 22, there's no way we would look at this thing and say, cancel out the 2's, it's 6 over 2, my answer is 3. Because think about what this is saying. 26 divided by 22 is what fractions are saying. If I had 26 bucks and I split it up over 22 days, I'd have just barely over $1 a day, maybe $1 and some change. I would not have $3. It seems silly to want to do that. Well, if I had 26 over 22, I could make the 26 20 plus 6. I could make the 22 20 plus 2. That's not wrong. It's not different. But I wouldn't then be able to cancel those out and say, oh, yeah, 6 over, it was 3. Again, these are ways that don't work. If we had a fraction, 26 over 22, because we're used to fractions, what we'd say is, yeah, they're both even. Divide by 2, divide by 2, I get 13 over 11. Which if I had $13 over 11 days, I would still have about $1 and some change. Fundamentally, think way back the first day we did fractions in any course, probably 3rd or 4th grade, prime factorization, those same prime factorization trees we talked about before. 11 times 2. So if I had 26 over 22, one way that I could look at it is, my 26 I could factor as 2 times 13. My 22 I could factor as 2 times 11. But that's what you're doing. When you say divide by 2, what you're doing is canceling out the common factors. That's what's really going on. That's where that 13 over 11 comes from, is when you factor it. Now, we got good enough that we were able to recognize what were factors and divide them automatically, but that's fundamentally what's going on. It's all about factoring, and this is going to be another useful application of being able to factor our polynomials.